Now saying you are unmuted. You are unmuted. Yeah, can you hear me? Hello? Can you hear me? You can hear me now? Okay, okay, okay. Yeah, yeah, now that error has gone, yeah. Okay, so whenever I lost, like, you just give me a missed call, then I will get in, I'll know this way. Okay. Yeah, Garima, can you hear me now?
You please go ahead.
Okay. So, sorry audience, sorry for the delay. There were some problems in the mic settings. So without any further delay, we will start with the seminar on Advanced Java. Today we will discuss the most important advanced concepts of Java, which we normally don't use in our day-to-day programming. So without any delay, we will start with the first important concept in Java which every programmer should be aware of. So how to measure the execution time for a Java method? See, whenever we write a Java method or a Java class, we should understand how much is the execution time for that method to understand whether the method has been written with a good coding practice or not. So we should understand the performance of a class by the performance of its method, how much execution time it has taken. So the best way is use system.current_time millis. So as you see in the current example, I have taken long start time and long stop time. In between start time and stop time, I have the method call. The method does something. So when I take the difference, I get the time elapsed. So in milliseconds, how much time the method has been taken. So suppose if my method is taking a lot of time, I can improve the coding in the method. I can decrease the lines of code. So, and thus improve the performance of my class overall execution. Next, we come across one of the important problems like which most of the Java programmers face these days, which is java.lang.out of memory error. So whenever we get an out of memory error or out of memory exceptions, we get frightened. What to do? So first we should understand that whenever any class is instantiated or loaded in the memory, what is that memory all about? So it is nothing but the JVM memory. We all know that JVM has stack and heap. In stack, we store the local variables or the private references, and in the heap, we store class level variables and objects. So we should understand that instances in the objects go into the heap. So we can always configure the size of a JVM heap. So at runtime also, we can do. As you see that whenever JVM spends 98% of its time in garbage collections and not more than 2% of its memory is free, then an out of memory exception is thrown. This is just a research analysis. So we see that the default size of a heap in Java is 128 MB. This, though it varies from JVM to JVM. So suppose I'm executing a Java program at runtime by the command Java and followed by the class name. So between that Java and class name, I can add parameters with -xms and -xmx. These two parameters set the default size or the starting size and the maximum size for the JVM memory respectively. So if you see in the example I've written, I'm setting the initial size to 64 MB and the maximum size to 256 MB. So this is one of the ways by which we can set the increase or decrease the JVM heap size and thus overcome the out of memory problems. You can also use JConsole tool or the runtime class of Java. In the runtime class of Java, we have methods like max memory, total memory, free memory, all of which we can use to query about the heap size to understand how much size our class is taking in the JVM heap. So this is one of the examples to get the heap size. You can see the command line. I've written runtime.getTime, runtime.total memory. There is another way